Hello everyone, you are welcome to today's lesson. And in today's lesson, okay, as you can see on your screens, okay, we are still on the topic, okay, polynomial functions. Polynomial functions. And take note, okay, the lesson that we have, today's lesson is lesson 7. Okay, and probably this will be our last but one lesson, if not the last lesson. Okay, in this particular lesson, okay, our ultimate goal, okay, or objective will be, okay, how we can use all the information, okay, all the knowledge that we've acquired so far on polynomial functions to deal with likely exams questions or, okay, past questions. So we are going to look at solution to selected past questions or likely exams questions. Okay, for some of the questions, okay, there are variations. They are not directly past questions, but I pick past question, then I varied it a little just to suit, okay, exactly the information I want to extract from you. And some of them too, they are direct. Okay, so let's quickly go and look at what the question 1 and how to deal with it. Okay, so let's see. When the polynomial f of x, okay, which is given by x cubed plus 5x squared plus px minus 1 is divided by x minus 2, the remainder is 7. Find the value of p. So you can see that, okay, unlike the one that we've been dealing with where usually it is direct or somehow close to direct, so that you are able to solve it. You know exactly what you are looking for. Here it is not like that. But this is how we are going to proceed. As usual, whenever a question is given, okay, we have to write solution. Okay, if the question is numbered, we write the question number, which indirectly becomes our solution number. Okay, then you extract the given information. So any information that you need, you extract. So given, okay, our polynomial f of x must be extracted. So, okay, I'm going to extract my polynomial. Remember, for every polynomial question, once the polynomial is known, it is key to extract that polynomial function. So here, the polynomial is known. So we are extracting. And what are we giving? We are giving is divided by, so this is what? A divisor. So I'm going to write the divisor. So divisor, comma. If you have space here and you can continue, you continue. You can go there, you continue there. So you are going to get divisor. Okay, and what is the divisor? The divisor is what? X minus 2. And when it's divided by this, the remainder, okay, we are told is equal to what? 7. Okay, so this is how you are going to proceed. Okay, now in a situation where you have only one unknown in your polynomial and you are asked to find, we need to give you one information, vital information that will help you generate only one equation to solve. Okay, so as usual, one letter unknown requires, okay, at least one equation to solve. So basically, we are good to go. We have all the information that we need. Okay, so we know if, okay, your polynomial is divided by, okay, x minus 2, and the remainder is what? 7. Then can I say that this implies that, okay, f of, okay, 2 is equal to 7. Do you agree? Hello, do you agree? Hello, are you with me? You agree, right? Okay, very good. So, can you know why it is f of 2? Was that the question? Okay, let me see. Which of my professors was that? Who was that?
This was the refer.
Have you watched all the videos?
Okay, I've seen it. Yes, I've understood.
I will be surprised. Okay, so you equate this 1 to 0 and you solve for the x, but we are matured, so we'll do that one mentally. Okay, so f of 2, let me write the 2 well. It's looking like x. Okay, so let me write it well. Okay, so that later when I change it to PDF and send it to you to revise for your test. You will see it clearly. Okay, so can I say that if f of 2 is equal to 2, is equal to 7, then it means wherever I see x here, I'm going to substitute, okay, the 2. So I can say that, or let me even write it this way so that you can, but that doesn't mean if you use implication, okay, you will be wrong. Please, you won't be wrong. Okay, I want to write it this way, but f of 2 is equal to 7 based on the information that we are given. So I can say that this implies that, what is my f of 2? It will give me 2 cubed. And you can still use implication here and continue like the way I have proceeded. So plus what? Okay, 5 into what? 2 squared. Okay, plus what? P into 2 minus 1 is equal to what? You said this should be equal to 7. So this will give us 8. Okay, plus 5 into 4. Okay, deal with the powers first. Then plus 2p minus 1 is equal to 7. All correct? Okay, so we are going to get 8 plus what? Okay,
Yes,
20 plus 2p minus 1 is equal to what? 7. So indirectly, I can write my 2p here. And you can see that anytime I'm writing, I write close to the margin. Okay, is equal to, I will add this. Okay, 28 minus 1. So that will give you 27. Then you move the 27 to this side, which will give you, okay, 7 minus 27. So that will give us minus 20. Am I right? My professors, is my point well made?
Yes.
Okay, if you want to combine this, somebody can choose to write here as what? Okay, this will give you your 27, okay, plus 2p is equal to what? 7 before coming to this. But you can always do this one mentally. So this will not, the mass will be given here. Okay, so at this point, don't forget, you write it again before you divide. Because you have a term each, okay, to each side. Okay, so 2. Okay, 2. So I will get p to be equal to what? Minus 10. I will ask to find the value of p, so I draw my conclusion. Therefore, p is equal to minus 10. Is my point well made, my professors?
Yes, please.
Okay, so remember, this I use this one to explain something, so I think I can clear it or move on. So this is the first, okay, indirectly past question that we've been able to solve. Okay, any questions? Remember, as you move from one question, that's how I arrange my questions. Okay, from one question to the next question, the level of difficulty will change. Okay, will be. So if you don't understand this, then it means the future is going to be very bleak. So make sure if you don't understand, let me know so that we are all okay at the same level. Okay, so if you understand, then we are good to go to the next one. So let's look at the next question. Okay, so when the polynomial f of x, which is 2x cubed minus s squared plus mx minus 2, is divided by x minus 1, the remainder is minus 6. Determine the value of m. Okay, that is I. Hence, factorize f of x completely. Then I find the true set of f of x is equal to 0. Okay, so this one 3 in 1. Okay, however, so you should know that the volume of work here, okay, will be more. So let's proceed. How do we start? Okay, as usual, after reading the question, underlining the salient parts, if any here, there is no salient parts to underline. Okay, so you come and write solution, then the question number. Okay, after that, what do? We extract. So what are we giving? Once the polynomial is given, okay, it came with a name, so you extract it with a name. If it didn't come with a name, they would have started let. Okay, so that would be equal to, okay, 2x cubed, okay, minus x squared minus mx, okay, then minus 2. Okay, that's not all. The divisor. So you've been given a divisor, comma, your divisor there because we are told it's being divided by, and that is what? Equal to x minus 1. Okay, and what is the remainder? You know the remainder will be equal to what? Negative 6. All correct, my professors? Are we all fine?
Yes.
Okay, great. So at this point, we are more than good to go. So just the same way. So you can see that the I is similar to what we did, okay, in the previous one. So what do we do? But from the question, we are told that when it is this polynomial is divided by this, the remainder is this. So it means f of what will give you -6. F of what?
1.
F
F
of
of
1,
1.
very good. F of 1 is equal to what? -6. Okay, so at this point, this implies, now what is your f of 1? Wherever you see x in f of x, it becomes 1. So it will be 2 into 1 cube, okay, minus, okay, 1 squared, okay, minus m into 1, okay, minus 2 should be equal to -6. So at this point, you get 2 into 1 cube, which is 1, minus 1 squared, which is 1, okay, then minus m minus 2 is equal to -6. So because you have one unknown, you were given one divisor and its remainder. Okay, so that's okay for you to generate the equation and solve for the unknown. So in this case, okay, my m is negative, so I always want to avoid, okay, working with negative. So in any case, this will give me 2 minus 1 minus m minus 2 is equal to what? -6. I have to remove all the brackets first. So I will move the m to this side and bring this one here. However, someone can choose to write it this way. Combine all that you have here. So 2 minus 1 minus 2. So you get -1 minus m is equal to what? -6. Okay, only that I wouldn't do that, but I'm writing it just for explanation purposes. So this will give you -1 minus m is equal to -6. Then now, okay, someone will keep the m here and move this one to the side. However, because my coefficient of m is negative, I always want to avoid dividing by negative if possible. So I will move this one to the side and bring this one here. So I will get -1 plus 6, which will give you 5. Okay, and that should be equal to, you move this one here, m. So now I will get what? Therefore, m is equal to what? 5. Is that clear? Okay, very good. But take note, okay, you can see that from here, I intentionally did something, okay, which possibly could happen to you, so that you take cue from, okay, the advice that I'm going to give you. So at this point, this is what you have. So let me write my m well. Okay, so you move on to, okay, you want to factorize. Once you know your m, you know the actual polynomial, so you can go and factorize the polynomial. So I. Immediately you write I, you ask yourself, have you written I that you are going to write I? Because all questions, okay, when you are solving, once the questions come with question numbers, your solution must equally have the same numbers. So it means here, you haven't done that. So when you were finding the m, you started from here. So it should be I. Is my point well made? But please don't wait for you to get to I for you to have the second chance to correct yourself. Immediately you proceed to find, after extracting the information, and you proceed to find m. That will be for I. I hope my point is well made. Okay, and I usually want to normal, okay, in the same way as well. You can see that the I came with only one bracket. I also came with only one bracket, so I will do same there. All right, so you can equally adapt. Okay, so now that will be it for what do you call it? I. Now we need to factorize. But before you can factorize this polynomial, you need to know the exact polynomial. From the beginning, it was a general polynomial because you didn't know the m. Now that you know the m, you know the actual polynomial or the specific polynomial. So you can factorize. So what do I do now? It means my polynomial f of x, okay, will be equal to 2x cubed, okay, minus what? X squared. Okay, then remember m is 5, so minus 5, okay, x, then minus 2. Do you agree? Okay, so this is the polynomial that we are going to factorize. But you can see that the polynomial, okay, is a cubic polynomial. So if you want to factorize, we have to use try and error to get one factor. Okay, and after that, we use the long division to generate the other factor or factors. Okay, so now we are going to do the try and error. So I'm waiting. If x is equal to what? Remember, if you want to use the try and error, okay, we consider factors of what? The constant here. So it will be plus factors of 2, which will be plus or minus 1, plus or minus 2. But the coefficient is not what? It's not, what do you call it, 1. So it means there will be another pool of factors to select from. But that one, you consider it if, okay, all the factors here, none of that gives you 0. Then you come and it means possibly you can get it from the second set. Okay, so deal with this one first. So do the try and error. I'm waiting. Which one gives you 0? Minus 1. So if x is equal to minus 1, okay, comma, we are going to get f of what? Minus 1. And that will be equal to 2 into minus 1 cube. Okay, then minus, in bracket, minus 1 squared, minus 5 into minus 1, then minus 2, which obviously you know will give you 0. So if you like, you can come and write equal to 0 here straight away, or you come down. I usually don't advise you write more than an equal to on the same line. Okay, so meaning you should have gone down, but I can't write here and I don't want to go to the next page too. But you, if this happens to you, go to the next page. Take note of that. Okay, so let me equally, once I'm advising you, let me also do same. Okay. Okay, so it means my f of what? Negative 1, okay, will be equal to 0. So this implies what is a factor? Hello, what is a factor? Okay, so x plus 1 is a factor. Okay, so you come and set up your long division. So x plus 1, remember you write close to the margin. Okay, I left a space here, a line here, because I know my quotient will go there. Okay, so now your given polynomial is now is your dividend. So you write it, okay, here, minus s squared, okay, minus 5x, okay, then minus 2. So with this question like this, okay, if you are spending all the time to find the m, okay, please do, or chunk of your time to find the m, or take your time to, because if m is wrong, I and I will be wrong. So m holds what? A key to a certain future. So make sure, okay, that future will be bright by, okay, getting the right m. Is my point well made?
Yes.
Okay, so at this point, what do? We set up our long division and we are going to proceed. So 2s cubed over x, and that will give us what? 2s squared. You write it on top of the term in the dividend with the same degree. So 2x squared here. This time, this will give you 2s cubed. Okay, this time, this will give you plus 2x squared. Then what do? We go and subtract. When we subtract, this will go. This will give us minus 3x squared. You bring down the 2 terms, minus 5x, then minus 2. You start the process again because the degree here is not less than this. So minus 3x squared divided by s, and that will give you minus 3x. Okay, so minus 3s times all the terms here will give you minus 3s squared. Okay, then minus 3x. Again, you come and subtract. And when you are subtracting, don't forget this. As for you closing it, I told you don't close it. Okay, so now this will go. Okay, and this will give you minus 2x. Because I'll get minus 5x plus 3x. Then you bring down the 2. So negative 2, you bring down the negative 2. So now the degree is also not less than. So this cannot be taken as our remainder. We have to continue. So this minus 2s over s will give you minus 2. So now you come and multiply this, which will give you minus 2x minus 2. So if you subtract, you know you get 0, 0. Okay, so you do this. And obviously you knew the remainder will be 0. So at least this will give you a clue, a hint that, okay, possibly you are on the right track. Okay, so at this point, now your first factorization will be your f of x, okay, will be equal to the divisor, which is x plus 1, okay, times the quotient, and the quotient is what we have up here, 2x squared, okay, minus 3x, okay, then minus 2. So this is your first factorization. However, the questions ask us to factorize completely. So if you like, you can, okay, underline that, okay, and in any case, let's factorization. I've told you whether you are asked to factorize completely or not. If the question is silent on completely, your factorization must be complete. Okay, so take notes. And in this one too, would have come to that. As for this one, there is nothing to underline. Okay, the I, you are supposed to underline hence, very critical. Okay, so take notes. So we're done with the I. Now I, when we read it, we should have underlined this. Okay, then when you come to the I, where you read it, you underline this. Okay, as well. The true set, very critical. Okay, so at this point, your factorization is not complete because we can see that this is still factorable. Okay, so let's see whether indeed it's factorable. 2 times minus 2 will give you minus 4. Can we get factors of minus 4? If you multiply, you get minus 4. If you add, you get minus 3, which will be minus 4 and positive 1. Am I right? Okay, so it means we can factorize. So at that point, maybe you write therefore, we'll draw a conclusion. Someone can write therefore here and come and write f of s is equal to, then you have one more step. But I didn't, so it means it's now that I'm going to draw my conclusion. So therefore, f of s will factorize into x plus 1, awaiting the factorization of this, which I'm going to do, or you are supposed to do as a rough work. So you have room here for your rough work. Don't come and do it here. Okay, other than that, you go and use some other lines that possibly you could have used to do something better. Okay, so that will give you 2x squared minus 3x minus 2. So 2x squared, okay, minus 4x minus, well, sorry, plus x, then minus 2. So 2x out, x minus 2, then plus 1 out, x minus 2. So this factorizes into 2x, okay, plus 1 into what? X minus 2. And like I told you in the previous meeting, I always want to write the pretty one first. And I regard the, okay, pretty one as what? The one with the coefficient of the x being 1. So I'll write that one first here, which is x minus 2, okay, followed by the other factor, which is 2x minus 1. So I am through with my factorization. That's why my conclusion is drawn. So it means now my factorization is complete. Take note of that. Point well made, my professors.
Yes.
Yes.
Okay, so this will be it for I. Now quickly, let's go and look at what I. Oops. Okay, so it means I have to create. Okay, so the slide couldn't take my solution. Okay, so now we move on to I. Okay, Prof. Janice, your hand is up.
Mr. Hackman, please, when you're factorizing, 2x plus 1, but you ended up writing 2x minus 1.
Oh, it was a big error. It wasn't intentional. So it's good. Other than that, I'm doomed. Okay, it means I will get the conclusion wrong and the follow-up will also be wrong. At least I'll get one of the values wrong. Okay, because my factorizing, because the I equally depends on what? On the I. Okay, so thank you very much for that prompt. Okay, so now I, we need to factorize. So we've been given, we are asked to find the true set of this. So you underline true set because, okay, it will guide you as to how to leave your final answer. So in this case, what am I giving? F of x, the information I can extract there is f of x is equal to what? 0. Okay, so this implies that now f of x, ordinarily you would have written this, but because you are equating f of x to 0, indirectly it's like you are finding the zeros of f of x. Okay, so we need to factorize the f of x, which we have. So instead of substituting the unfactorized form of f of x, we'll go and substitute what the factorized form. And the factorized form gave us what? X plus 1, x minus 2, then 2x plus 1. So that's what we are going to write there. I hope you are following.
Yes, please.
Okay, so it's equal to 0. So you set each of the factors to 0. So x plus 1 is equal to 0, or x minus 2 is equal to 0, or okay, 2x plus 1 is equal to 0. You come and solve for x in each case. So x will be equal to negative 1 here, x will be equal to 2 here. However, this one you need, okay, to do a little more work. Okay, you write it again before you divide. Over 2 over 2. Okay, so at that point, though I have not found the s value here, I can write the value in my conclusion. So therefore, okay, it is the true set. So your answer must be in the true set form. X is such that x will be equal to minus 1 or 2 or minus 1 on 2. Then you close it. All correct, my professors.
Yes, please.
Okay, any questions at this point? So you can see that if you don't take care, and that's why I have advised you, make it part of your plan to always underline the salient part so that you protect, okay, especially the low hanging marks. So you can see that when you underline this, you didn't leave. If you don't take care, you might be tempted to conclude the usual way, which is not the true set. Okay, so underline to take, okay, or protect what our marks. Okay, so all clear.
Yes, please.
Okay, so let's look at the next question. Okay, so obviously once it's in green, you know that I cannot handle it. It means this question, you are likely to see it in your class test. So you are going to try. Okay, take notes of that. You are going to try. Okay, that one later. Okay, so let me see. Okay, at this point, we are going for our water break. When we come back, then we look at the rest of the questions. Okay, so welcome back from the water break. Okay, so like I said, the question 3, okay, likely you see it in your test, so make sure you practice. Okay, all right, now let's look at question 4. Okay, quite different from, okay, the questions that we've dealt with so far. Okay, so let's see. If x plus 2 and x minus 3 are factors of the polynomial, okay, 2x cubed minus ps squared plus qx plus 6, find the values of p and q. So unlike the first, I think, should I say 2 examples, the third one we didn't do. Okay, even the third example, you had only one unknown. Okay, letter to find, but here you have 2 letters. So remember I told you, if you have one unknown, we have to give you at least one divisor to find the unknown. If you have 2 unknowns, at least we have to give you 2 divisors to find the unknowns, and you can see. Okay, you've been given divisors, only that they are special divisors, which are factors. When you have this situation where you are given more than, please take notes, when you are given more than, okay, a divisor, this is how I will advise you to proceed. Okay, this is it. Okay, so the first thing, you need your polynomial. For every polynomial question, okay, the polynomial function is key, so that's what you extract first. Okay, no matter where it is put, that's what you extract first. However, this polynomial unfortunately didn't come with a name, but fortunately we know and we can name it. So we are going to write, let your polynomial be f of x, okay, which will be equal to px squared. Sorry, I left the first term. Forgive me. Okay, so we do choose 2s cubed, okay, minus px squared, okay, then what, plus qx, okay, then plus 6. Okay, however, this is what we are going to do. Because we have more than, okay, one divisor given, I will entreat, okay, and advise you to extract the information in a table form. Okay, by that, this is what I mean. Okay, your table will be this. Your first column will be headed divisor. Okay, and your second column will be headed remainder. Is my point well made, my professors? So the first divisor is x plus 2. Okay, what do you think the remainder will be for this divisor? The remainder will be, okay, Prof. Refua, it will be
0.
0. Very good, because it is a factor. Okay, then when you come to the second one too, it's a factor, so your divisor x minus 3 equally will give you, okay, a remainder of 0. So now, like I said, when your divisor is more than 1 with its corresponding remainders, either given directly or indirectly. With this one, the remainders were not given directly, but indirectly you knew that once it's a factor, the remainder or the remainders will be 0. So now what do? You come and start. Okay, you use each divisor, okay, and its corresponding remainder, this information to generate an equation each, and you solve, because you need 2 equations to solve for 2 unknowns, at least 2 equations. So now you come and write, but you know if you take the first one here, f of what? Negative 2 should be equal to 0. Do you agree? Hello, my professors, do you agree?
Yes.
Okay, so you proceed the same way as if you were given only one, okay, information. So this means I will get 2 into negative 2 cube, because f of negative 2 means wherever you see s in f of x, it is negative 2. Then minus p into negative 2 squared plus q into negative 2, okay, plus 6, which you are saying should be equal to 0 because the remainder is 0. So now this gives you 2, negative 2 cube will give you, okay, negative 8. So 2 into negative 8, then minus p into negative 2 squared will give you 4. Okay, then this will give you minus 2q. Okay, then plus what? 6. Okay, and that should give you a 0. So at this point, what do? You remove the bracket here. Minus what? 16, okay, minus what? 4p, okay, minus 2q, okay, plus 6 is equal to 0. Now you know normal equations with 2 unknowns, okay, usually we would want to should I say yes, we would want to make sure that your terms with the unknowns are on one side and the other terms are on the other side, okay, of your equal to. So now we are going to keep this one, okay, which is the minus 4p, okay, minus 2q here, and move the constant to the side. But the constant you can combine. Minus 16 plus 6 will give us minus 10, and you move it to the other side. So that will give you 10. All correct. My professors, is my point well made?
Yes, please.
However, okay, like I have told you, if I haven't, I know I have told you. Anytime you have an equation you are going to label, make sure that the equation does not contain brackets, if possible. If you can avoid that, avoid. If you're make sure also that your equation will not contain fractions. If you can avoid fraction, avoid brackets, avoid. And again, if your equation can be reduce before you label it. Can this equation obviously does not contain brackets. Our resultant equation here, it doesn't contain, okay, fraction 2. But can we reduce it? Can we?
Yes.
Yes, we can, because we can see a common factor 2. So we can divide by 2. However, I will not divide by 2. I always want my leading coefficient to be positive. So instead of dividing by positive 2, I will divide by negative 2. You get the point?
Yes, please.
And okay, because you have more than, okay, one term on one side, you can choose not to show the division by the 2. You do it, or by minus 2, you do it mentally. The only situation that you are advised to write again then divide will be when you have a term, okay, to each side or on each side. So it means this over negative 2 will give me 2p. This over negative 2 will give me plus q. This over negative 2 will give me minus 5. So I will label this one as my equation 1. All correct.
Yes, please.
Okay, then I come to end. So my second information. So and here f of what should give me 0.
Yes, of course.
F of 3 should be equal to 0. So you are going to use this information also to generate your second equation. So this implies that, okay, 2 into 3 cube, okay, then minus p into 3 squared, okay, then plus q into 3, okay, plus 6 should also be equal to 0. All correct?
Yes, please.
Okay, so now what do we do here? We are going to remove the bracket, but deal with the powers first before the bracket. So you get 2 into 3 cube is what? 27. Okay, minus p into 3 squared is 9. Okay, then plus 3q. Okay, plus 6 is equal to 0. So we move on to the next. Okay, we are going to get what? 2 times 27 will give us
54.
54. Okay, then minus 9q, 9p, sorry. 9p, then plus 3q. Okay, then plus your 6 is equal to 0. And like I said for the other one, okay, you know every equation usually you would want to, okay, maintain the, have the terms with your unknowns on one side and the other terms on the other side. So this will give you minus, and you can see that's I write close to the margin. Minus 9p, okay, plus 3q, okay, will be equal to, now 54 plus 6 will give us what? 60. So you move that one to that side, so that will give us minus 60. All correct. Okay, this equation does not contain fraction, it doesn't contain brackets, but can we reduce it?
Yes.
Okay, we can. So we would use it by dividing by what?
Minus 2.
Okay, like you can divide by positive 3, but remember I said use the sign for your leading coefficient. If it's negative, divide by negative. Okay, so to make it pretty. Okay, so minus 3 is what we are going. So this one over minus 3, we are doing it mentally. Okay, so over minus 3, the minus will cancel. 3 will go here, 3. So we get 3p here. Okay, then this over minus 3, the minus will take, so minus will come here, the 3 will cancel, then you get q. Okay, this over minus 3, the minus will cancel, then you get 60 over 3, which will give us what? 20. Am I right? Okay, so this then becomes equation what? 2. Okay, so now you can see that because you reduce, assuming you didn't reduce this equation, and you didn't also reduce this equation, and you were going to work with this equation, you can see that you wouldn't. Hello, are you with me?
Please, how do you get
Minus Q.
minus
It's not
Q?
supposed to be Q.
How did I get minus q?
Yes, please.
Okay, someone is there
Because
with
the 3
you.
is positive.
Someone is there with you. Someone is there with you. Very soon I'll ask you to turn on your video so that I see her face. Okay, all right. Remember we were dividing by negative. So if we are dividing by negative, all negatives will be positive and all positive will be negative. You get it?
Yes, please.
Okay, and I want the person who is standing by you also to respond. Eh? I want the person also to respond because she also didn't get
Yes.
it. Eh-heh.
Please, the 3 is positive.
The 3 is positive. Which
Yes.
3? Which this one?
Yes, please.
Okay, it's positive. Yes, so but we were dividing by negative 3. So
Okay.
if once you are dividing by negative or you are multiplying by negative, all positive will tend to negative and all negative will tend to positive. That's why this negative became positive, this positive became negative, and this negative became positive.
Okay. Thank you.
You are welcome. Ishra, you after the class, I will call you. Okay, so this is what we have. All right, so now I think we are good to go. But I was making a point then you came in. I was trying to say that if you had not reduced the equations and you label this as your equation 1 and this also as your equation 2, you wouldn't see that you can easily eliminate Q by adding. Can you see that? So if you fail to do that, it means there will be more work to do or to be done in the near future. So that's why usually we advise you reduce your equation. Probably when you reduce, you can see that you will be dealing with small numbers. Even if you can't directly eliminate, you'll be dealing with smaller numbers, which will make your work convenient. So in this case, I am going to eliminate. Anytime you are solving equations, listen, because you have basically two methods. We have a third one anyway, okay, but because that one is graphical, we don't talk about it. Okay, simultaneous equation, that is elimination and substitution. But always listen to your equations. They will tell you the best method to use. And having listened to the equation, I heard the equation telling me that elimination will be the best way to go. Because coefficient here is -1, this is +1. I can add to eliminate. Okay, so at this point, I am going to write equation 1, okay, plus equation 2. Okay, I'll write it. This will be too short to take a line. So I'll write comma, then come and add mentally. So equation 1, so 2p plus 3p will give us 5p. Okay, plus q plus minus q, that will give you 0. That was your intention. You wanted to eliminate q. So q is gone. It's equal to, then you get -5, okay, plus 20, and that will give us what? 15. Am I right? My professors, am I right? I hope you
Yes.
are with me. Are you flowing with me, my professors?
Yes, please.
Okay, so at this point, we write it again. So 5p is equal to -15, sorry, +15. Okay, so +15. And here we are writing it again. We didn't divide mentally because we have, okay, a term to each side. So we will show our division. Okay. Okay, so that will give us P to be equal to which value? 3. But you need P to find Q. So it means you have to label this equation as equation 3 because you are going to substitute. So that you write equation 3 into, and please avoid you writing equation this way. In short form, then maybe 1. Okay, it's not universally accepted. EQN is not universally accepted. So just label your equation and use the labeling. Okay, and don't write puts. If you want to write puts, instead write putting. Don't write substitute. If you want to write substitute, instead write substituting. But it's not necessary. Just write 3 into, which one do we go for? Are we substituting that one into 2 or equation 1? Always go for the one that will involve smaller values. So I will go for equation 1. So 3 into equation 1. Okay, comma. This will always be too short to take a line. So you bring a comma, semicolon, anything to separate that from whatever that you are going to write. So that will give me 2p. So p is what? 3. Then plus q. And that should be equal to -5. So I will get 6, okay, plus q is equal to -5. So that gives me q, okay, to be equal to -5 minus what? 6, which will give me -11. All correct. Okay, so at this point, I come and draw my conclusion. Therefore, okay, P is equal to 3 and Q is equal to -11. All correct. Sure. Are we all fine, my professors?
Yes, please.
Am I teaching well? Okay, that one you didn't respond so quick. Okay, so it means we are fine with this. So the next question will equally contain two unknowns. So if you are able to do that, then I think our understanding, okay, is up there. Okay, so now let's see question 5. Similar to what we just did, only that we'll go, okay, further by finding the zeros, making use of what the A and B. Here, okay, the previous one, we just found our unknowns and that was it. Okay, all right, so let's look at this one too. The same thing. Okay, only there is the I that makes it, okay, somewhat different, but it's the same thing. So let's look at solution. Anything for you to underline? Okay, when divided by, okay, you extract the information anyway. Okay, so you are supposed to find the zeros. Okay, so now solution to question number 5. Okay, given, thankfully the polynomial came with a name. So maybe given, or you can ignore the given, but you cannot ignore, okay, extracting the polynomial, okay, which came with a name. So ax squared, okay, plus 6x, okay, plus b. So let's see what is going to happen. Okay, then now you can see that you have two unknowns. So obviously we have to give you two devices, either directly or indirectly, for you to deal with it. Okay, so let me clear this and write it well. My professors, are you following? Okay, so because you have two devices, each of them, okay, with the corresponding reminders given. So what do? You extract. When you have two factors, extract the information in the table form. Remember the advice. So your first one is the divisor, and your second column will be the remainder. Okay, it's convenient for you to extract it this way. So your first divisor, okay, we are told, okay, where a and b are constant, has x minus 2 as a factor. So it means x minus 2, which is your first divisor, will give us a remainder of 0. Do you agree? Okay, and our second divisor, when divided by x minus 1, so your second divisor is x minus 1, the remainder is 4, so it gives us a remainder of 4. You get the point? So the table indirectly is giving you the picture that we have up there. Okay, so now that we have this, remember, you have two unknowns, so you use each of these to generate, okay, an equation, then you solve the two equations simultaneously for your two unknowns. So here, okay, Prof. Inshira.
Is it necessary to draw the table when you are solving it?
Yes, that's why I advised. Okay, any advice
Okay.
indirectly, okay, I will say that it is necessary.
Okay.
Okay, otherwise you can write x minus this, okay, remainder is this, but you can see that if you do that, you write more. You are going to write divisor twice. You get it? When you are extracting, you write
Yes.
divisor twice and remainder also twice.
Yes. Yes.
So, like, I'm experienced. Okay, so whatever I do, I will tell you to do to save time, because always in exam, time will not be a good ally. And sometimes we are not able to get the score. Not that you don't understand, but because, okay, time was not enough for you. And time will not be enough for you if you don't know the ideal way to present your solution. That's why you write a lot and waste time. So any advice that I give you, take it. It is for our own good. Remember, your marks are mine as well. So at this point, I come and write, but what do we have? F of what? 2 should be equal to 0. So we use this one to generate our first equation. F of 2 means wherever you see x in f of x, you replace that by 2. So that will give you a into 2 squared, okay, plus what? 6 into 2, okay, plus b, and that should be equal to 0. So that gives us a into, deal with the power first. So 4 plus what? 12 plus b should be equal to 0. So you get what? 4a. Okay, I am rearranging and moving. So plus b is equal to minus 12. I hope you get the point. Are you with me, my professors?
Yes, please.
Okay, so at this point, no fraction, no brackets. Can we reduce? Can we reduce the equation? Remember, it should satisfy these three before we cannot reduce, so we can label it as our equation 1. Then let's go to the second one. And remember, okay, throughout my presentation, I will not leave any line unattended to, so there wouldn't be any spaces. The only point that I will leave a line will be where I'm moving from a sub question to the other. I thought maybe, okay, someone would have advised me or maybe prompted me to do something because of previous advice that I gave you. Remember, immediately you extract and you know that you are going to solve I, make sure you come in. Okay, get your I there. It's not always that when you get to I, you remember that you need to go and check for I. Is my point well made?
Yes.
Okay, so and okay, f of what will give us 4? F of 1 will be equal to 4. So this implies that f of 1 means wherever you see x in f of s, you put 1 there. So it will be a into 1 squared, okay, plus 6 into, okay, 1, then plus b. And that should give you 4. So what do we do here? We get a into 1, okay, plus 6 plus b is equal to what? 4. So you end up getting a plus b is equal to 4 minus 6, which is minus 2. Again, no brackets, no fraction, cannot be reduced. So we label this as equation 2. All correct. So now you listen to these two equations, okay, they will tell you the best method to use. Okay, if elimination is the best method, then what the variable that you want to eliminate, they should have the same coefficients, neglecting the sign. If I want to eliminate A, it will not be easy because they don't have the same coefficient. It means I have to multiply this one by, okay, something to make the coefficient the same. Okay, if I want to eliminate B, yes, coefficients are the same, so I can easily eliminate B. So I will go for elimination. Okay, so on that note, I'll write, okay, equation, I want to eliminate, but the signs are the same. So in order to eliminate, I have to subtract. Okay, however, when you are eliminating B, okay, and you are subtracting, because you want your result, your final result will be in A, go for the equation with the bigger A, so that when you subtract, you get a positive number and you don't divide by negative. So I will do equation 2 from equation 1. So that will give me 1 equation 1 minus equation 2. And this will always be too short, so comma. So that means I will get 4a minus a, and that gives me 3a. Then I will get b minus b. That will give me 0. That was my intention. So b gone. Okay, eliminated. Then I will get minus 12 minus 2. So it will be minus 12 plus 2, and that will give me minus 10. Am I right?
Yes, please.
Okay, very good. So at this point, we are solving for a term here. We can't, okay, divide mentally. We have to write it. Okay, show our division. So it means 3a is equal to minus 10 over 3 over 3. So you get a to be equal to what? Minus 10 on 3. Okay, I will need a to find my b. So I will call this equation 3. Then go and write 3 equation 3 into which equation? Okay, into equation, between these two equations, this one involves smaller values, so I will go for equation 2. Remember the advice. Okay, so on that note, I'm going to get a, which is minus 10 over 3, okay, plus b is equal to what? Negative 2. Is my point well made, my professors?
Yes.
Okay, so at this point, you have an equation in B which contains a fraction. So we are going to multiply through by the LCM. And because, okay, one of the sides contains more than a term, you can do your multiplication by, okay, clearing the fraction, which is the LCM, okay, mentally. So it will be this 1 times 3. The 3 will go, so I will get minus 10. Okay, this 1 times 3 will give me plus 3b. Okay, this 1 times 3 will give me minus 6. I hope you are following my professors.
Yes.
Okay, so at this point we are looking for B. So we maintain this one, remove this one here. So 3B, remember when I'm writing, I write always close to the margin. Okay, so it's equal to minus, 6 plus 10, which will give us positive 4. You write it again before you divide. Don't forget this. Okay, over 3, over 3. Okay, so you have your B to be equal to, 4 on 3. So I know the values of A and B. I go and draw my conclusion. Therefore, A is equal to, remember A is an improper fraction. You cannot conclude with an improper fraction. I didn't change it because I knew I will use it, and I knew I was not concluding with it too. So A will be what? Let's change. So minus 3 whole number 1 on 3. Am I right?
Yes, please.
And B will be equal to, this will give us 1 whole number 1 on what? On 3. All correct.
Yes.
Okay, so that will be it for the I. Okay, so we are going to move on to the II. Okay, so now we move on to the II. What are we supposed to do? We need to find the zeros of this, but fortunately for us, the polynomial function is quadratic, so finding the zeros will be very easy. Only that the coefficients, A and B, are not that pretty. So here, if you look at what we have, let me go and continue. Okay, the II at the back. Okay, so I'm going to write it. In any case, I didn't want to be moving. So II. Okay, so now your polynomial f of x, will be equal to A. A gave us, and when you are substituting, please never substitute the mixed, number version. Other than that, you have to change again, so it will be double work. So A is minus 10 on 3. Okay, so we substitute that one. So all of them, you substitute the corresponding improper fractions. So minus 10 on 3, x squared, plus 6x, then, plus what? Plus B. And B is what? 4 on 3. I hope I'm right.
Yes, please.
Okay, at normal circumstance, so at this point you come and write for the zeros. Oops. Okay, so for the zeros, your f of x should be equal to 0, and this is your f of x. So minus 10 over 3, s squared, plus 6x, plus 4 on 3 should be equal to 0. So this implies that now, we need to clear the fraction. The equation is not that pretty. So you can multiply through by the LCM, which will be 3. But because this side contains more than a term, when you are doing your multiplication, you can always do it mentally. So this 1 times 3, the 3 will cancel. So you get minus 10x squared. This 1 times 3 will give us plus 18x. This 1 times 3, the 3 will cancel, so plus 4 is equal to 0. All correct. Is my point well made, my professors?
Yes, please.
Okay, so at this point, you can see that this equation here can be reduced, true or false? So it can be reduced, so you reduce it before, you start solving. However, because the leading coefficient is negative, when I'm going to divide, I will divide by negative. So, we can divide by negative 2, is that not it? So negative 2, this one, so it means all the terms that we have there, the negatives will become positive and the positive will become negative. So this is negative, you divide by negative, it will become positive. So it will be positive 5x squared. Then this will be negative, so negative 9x. This will be negative, so it will be negative 2 is equal to 0. All correct. So if you had not divided, you would have multiplied this by this, which will give you a bigger number to find the factors, which will, and once your number is big, the factor pair will be a lot for you to choose from, which will be a little bit, confusing, or not convenient. So at this point, you multiply 5 and minus 2, so that will give you minus 10. You are looking for factor pair of minus 10. When you multiply, you get minus 10. However, when you add, you get a coefficient here, which is minus 9. So that will give us which factor pair? Negative 10 and positive 1. Are you with me? Okay, so you write 5x squared. You split this one into negative 10x. Okay, then plus x, then minus 2. Okay, we are almost done. Okay, and this we are told is equal to 0. So now you group the first two mentally and factorize. So 5 out, x also out. Then you get x minus 5. Then this will give you plus 1 out. So x minus 2, forgive me. Okay, 1 out, then x minus 2. Okay, it's equal to 0. Okay, so at this point you get 5x plus 1 in one bracket, in another bracket, x minus 2 is equal to 0. So you come and set each of the factors to 0 and you solve. So you get 5x plus 1 is equal to 0. Don't forget the connector, or x minus 2 is equal to 0. So with this one, you can easily solve for s equal to 2. You write that one, okay, and come and work on this one. Minus 1, 5x is equal to minus 1 again, over 5, over 5. So at this point, was I asked to, I was finding the 0, so I don't conclude with a true set. So I'll come and write, therefore, x is equal to the first value here, minus 1 on 5, or the second value, which is 2. So this will be the zeros. We are done. All correct, my professors. Hello, is my point well made, my professors?
Yes, please.
Great. Okay, so okay, at this point and on this note,
Yes,
okay,
please.
we bring the curtains down. Okay, on the first part of what solution to selected past questions or likely exams questions. Okay, so this then once you see this one here, it means likely you will see it in what in your class test. So take note of that. Okay, and this becomes what your assignment. So on this note, thank you very much for making the class interactive, though not to the point that I expected, but at least it was okay. All right, and God bless us all. Okay, so there was something that I intentionally left out. I thought maybe you would draw my attention to that. I equally forget, was intentional, but I forgot. Okay, so I think it was this question, the hence, the second part. Hence factorize. So in this case, please take note. Okay, in your conclusion with the factorization, don't use therefore, use hence. Hence, so your conclusion here should be hence. Is my point well made?
Yes, please.
Okay, take note of that. On this note, thank you. Okay, once again, and God bless us. Okay, all. Okay, once again.